So I think I just give one task to complete about to predict the future predictions. So let's build this. So nobody's tried this one. So let me share you those things. So this is logistic regressions we build, isn't it? One moment. Okay, so can you hear me? Team, can you hear me online, guys? Just give me quick confirmations, please. Yes. Okay. Let's do this. So good morning. Good morning, Abhilasha. So here, everybody know till how to build the confusion matrix and how to check the accuracy and how to check the bias and how to check the variance. So means we build the models using historical data, isn't it? We build the model using historical data. Sometimes voice is breaking. Let me know, Ashim. Let me know if it still exists or it's happening for a long time. So definitely I have to connect with my phone as well. Okay. So now let me build the model. I mean, we already done this before, so I just don't want it to explain again. Voice is breaking. Just 1 second. One second. Yeah. Now it's better. Yes, guys. It's better now. Cool. Yeah. So let's start. Let's start today's sessions. So here we build the model. And we check the bias and variances, and we check the model accuracy. All those things is done. So we build the model for historical data. In historical data, we already knows whether the customer is purchased car or not, isn't it? Now, what I said I have future data. This is the future prediction CSV file. I share you Excel file, isn't it? I didn't share CSV file. You have to convert the Excel file to CSV file. That is the first step, right? As this is the future customers, okay? And we are going to predict these these data points, and I wanted to predict what is the predictions. So what I said, you need to pass this data set to the existing model. What is the model? Classifier. Yes, guys. What is the model? Classifier model, isn't it? So now let's do this. At this moment, I build the model with 4 attributes or 2 attributes, guys. 2 attributes. Now, if I pass entire 4 attributes to the model, there is error. Yes, because the column issues, right? So we build the model with age and salary, but at this moment, I cannot pass all those things. So let me explain you. So how I done, this is the way to predict. So everybody, can you please push it, buddy? Please push it here. So here, let's say dataset 1 equals to pd.read.csv. Okay, this is the new file. I created dataset 1. Understand? This dataset 1 holds future data, which is 10 records. Clear? Now, I create another variable is called d2 because dataset1.copy. Let me execute this one. So let's open d2 and dataset1. Both would be same, isn't it? Both would be same. I'll tell you the reason why I've been done that. This one, dataset1 equal to dataset1.ilog 2,3. Agree? Because we need to pass the future data to the existing model. Existing model was built with 2 attributes, isn't it? So here, let me execute this one. Now let's check the dataset 1. Got it? Clear? This is the future data. Now, can I pass directly? Do you want me to scale it or not? Of course, the scaling is mandatory, isn't it? So what I need to do here, so I can say this from sklearn standard scaler online team. I hope you can hear me now. Yeah. Standard scaler s equal to standard scaler m. I just create a variable called m sc dot fit underscore transform dataset one. Correct. I need to pass the data sets to scale the data. Let me go for and scale it. The moment when you check, open the M part. This is the scale data or not? This is the scale data. Now go to the data set one. This is the future data. This is the scale data. Now, the next part is I have to create a data frame. I have to create a data frame because I don't want to pass each and every one line to here. So I need to make a predictions right over here, isn't it? Which is called D2. So I create a D2 duplicate or not? Where is D2? Just one moment. D2. I want to predict here so that my all columns should be stay. Do not remove any columns so anybody can figure out the user ID is this one, gender is this, age is this, and salary is this, and prediction should be here, isn't it? Now in this case, so what exactly create a data frame? D2 ypred1 is the data frame create ypred1. Okay. Now D2 ypred1 equal to classifier is what? Logistic model. Predict M. M we scale it, right? So it's very simple. The moment when I done this, let's check. Let's check. Okay. D2 ypred its predictions is done, guys, right? ypred1 the predictions is done. I mean not this one. Okay, these are the column names. Now what D2 to CSV final one dot CSV. Now I said whatever the prediction is stored by ypred1, I need to convert to the CSV file. Let me open this one. So once I open this, what exactly output get now? Let's close this. If you want to check the path where exactly I have, so I think import OS and os.getCWD and functions. So this is the path we have. So KData desktop, data science projects, NLP web scraping, what's getting here? XML many articles. One moment. Code, just 1 second. Data science projects, NLP web scrap, XML many articles. You get this one. Let's copy this one and I'm gonna paste here. Now open this file. Open this file. Team, I hope you understand now. This is what the correct predictions. You get it? Has anybody got this output? If anybody got this output, then your prediction is correct. What is the accuracy of this model? What is the accuracy? 92%. Means based on existing history data, the accuracy is 92, right guys? So let's say in upcoming days and future, this customer will visit to the store, and if he purchased not purchased item, then it's 0. Then he purchased 1, then this is a first level of testing. Then this is a first level of testing. Now I hope you can build other algorithms, guys. Can you do this? Everybody's clear online, guys? Yes, team, I hope you can hear me. Yes, guys. Yep. So the very simple, this is the way you need to build the future predictions, and you understand how to do this. I will share this code today so you can do it. You can do it. Okay, guys, you can do it. Now, yesterday, what we completed, support vector machines. In support vector machines, we done for the same data set. Let me explain this one. Don't save. Just go back to here. File, new file. Just 1 second. June or conditional probability. I'm sorry, May month 31st. Right. So this is the path we have here. So today you can build for KNN as well. All right. And then SVM as well. And you can post your future predictions for the existing data. Yes, guys. Now let's restart the kernel. Let's restart the kernel. Just one moment. Scaling is required or not, guys? This data. Feature scaling is mandatory. Okay. Scaling is mandatory. The very simple train test split, I can go for 20%. NumPy, Matplotlib, Pandas, as it's quite common. And then how many polys we have yesterday? How many degree poly I'm sorry, kernels. How many kernels we saw, guys? 4. Sigmoid, linear, and RBF and poly kernel. Yes. So poly kernel. Yeah, 4 type of kernels. So here, see this is NumPy, Matplotlib, Pandas we done. And we call the data set. This is the data sets we have. And from the same data set, I build the testing sample is 20% and training is 80%, right, guys? Now we scale the data. Somebody's asking about the scaling part, right? How to scale. Let me tell you guys, classifications does not require the graph. Okay. So no need to worry. I think somebody asked me yesterday, sir, can you please explain the code for the graph? That's okay. So classifications does not require graph. It's better. I will explain AUC and ROC curve. What is meant by AUC curve? What is meant by ROC curve? How we get those curves? I will explain tomorrow. Sorry, I just don't have. The next one, muted? No. So SVC, support vector classification, support vector regressions, right? If I click this one, let's go back, scroll up. C equal to 1.0, kernel RBF, degree 3, gamma scale, coefficients 0, shrinking true, probability false, right? So here, all those things, what happen? This is the parameters. These are the parameters, right? What is the by default parameters we have at kernel part? RBF. Yes, guys. If I scroll down, did you see this, guys? Very important part. Linear SVC or SGD classifier, stochastic gradient descent classifier. Yes. So parameters, default is 1.0, regularizations parameters. Okay. Kernel, linear, poly, RBF, sigmoid, and pre-computed. Yes. That's what I'm saying. We missed one yesterday. So which is called pre-computed. So by default is RBF kernel, isn't it? So in RBF kernel, default is 3. Degree of the polynomial kernel function is poly, ignored by all other kernels. So I hope yesterday, just one sec. So what is the logistic regressions accuracy we got? 89 or 92? Okay, what about KNN? Just one second. 95, right? KNN we got 95. Just one moment. Yes, Dakshani. So here, let's close this. Yes. So let me scroll down. See, guys, yesterday I shared this notebook. Have you checked this one? Yes, you checked this one. And today is first. So let's say logistic regressions, we got the accuracy of 92.50, isn't it? Or 89.50. 92 or 89? KNN. Okay. KNN 95. Yeah. KNN 95 with hyperparameter tuning. Yeah. So this is with Shekhar, understand? Hyper Rashmi. Okay, good. So let's KNN, we got 95, and let's gonna build with this model now. And we're going to see this here. So by default is RBF. So I'm not going to do anything. I directly build the model and let's check what could be the accuracy with parameters. And then we're going to build with hyperparameter with change to RBF to poly to rest of things. Yeah. So predict text test and now build the CM. What would be the accuracy, guys, for this one? The test sample is 80. So 50 plus 21, how much? So let's check this one. 95 again. For this one also, 95 we get it, right? So now what exactly happened? Let's see, does it bias? 90, okay. And variance? Maximum, because we build the model test data, so variance always be almost equal. So what exactly happened? So SVM also we got 90, 95 or 96. You know, guys, same data set. Let me tell you. Same many models. Understand? We build many models or many algorithms. Whichever models gives you highest accuracy, that we go for a deployment. I will tell you the deployment later part. All right. I will tell you the deployment after complete all the machine learning algorithms. We will talk about this. Clear? So support vector machines is 95% with parameter tuning. Yeah. Let me try. So here, what was the degree? What was the degree over here? Please, no problem. Come. So what was the degree here? 3. So can I change the degree to 5? Let's do this. So we go back to here and I could say kernel RBF and let's copy this and I'm going to pass the data here and 3 to 4 and RBF to poly. Yes, 1 degree have been increased. And let me try this. Let me try even the 0.5% increased. It's a good only. Yeah. So let's build this. Let me. $82. It's decreased. Yes, guys, it is reduced. And when you check this one, so bias, this is 81 and variance also 82.550. So I would say poorly. And if I talk about RBF, let's do this, restart the kernel and let me run this. Same logistic regressions, future predictions I explained you right now. So what you need to do, you build for SVM, you build for KNN predictions, and you need to show the report. I think you're taking recording. No. Okay. I just while ago I was explain how to make a future predictions. Okay. So please work on it and you build rest of things to the same future Excel. Okay. Yeah. So this one. So let me check this out. Again 95, isn't it? So again 95. So here other okay, let's try other kernel. Want to talk to take to as gamma is scale and I'll set gamma equals to auto and here and let me check it. Let me try last time. Even the 1% is increased, that sound good, but even the 95 is not a bad one. Let's go for this one. Same. Yes, guys. So I'm getting same info here. So I think this is the optimal one. I think this would be the optimal one. So here, sigmoid you're not going to use because let me try sigmoid as well. What is the sigmoid curve ranges, guys? 0 to 1. Okay, 0 to 1. So let me I'll show you today. I'll show you some of the interview questions. Let's see this. Right, Drakshani. It's again decreased. Yes. So the best one is RBF only. Okay. So this would be the optimal again, guys. So this would be the optimal. So I can stick with 95 only, not more than that. Okay. Yes, we can go with 95% only and not more than. So SVM also with parameters and without. So this would be the optimal part. So logistic regressions gives for the same data set, logistic gave 92 and KNN gave 95 and SVM gave 95. And next naive Bayes algorithms, I will explain a little bit late for this one because I will take 2 days to complete because very important. And I'll explain a lot of use case for this naive Bayes, you know, and how exactly the naive Bayes will use. Let me tell you guys, I'll give one real-time scenario. Every day, IRCTC server is down at midnight 11:30 p.m. Has anybody noticed that? Why it is downloading? I mean, why it is down? So no, that's not maintenance. So let me tell you what this is called historical data. Yeah. So how many data I have? So I have data, I think 400 records, right? So means entire IRCTC app is built on ML machine learning model. Okay. Machine learning model. Let's say yesterday you build the model. Understand? Yesterday you build the model, ML model. So today the new passengers is enter into the app or not. So every new passenger record is a new data. The model we built till yesterday. Understand? So new passenger is entered the record till today. Yes. So whatever today's passenger is entered, that has to be retrained to the historical data or not. I mean, till 400 records passengers, we build model. Yes, buddy. We build model which is called logistic or maybe naive Bayes. This is very important, naive Bayes. So today, another 500 passenger added or not? 500 passenger added. So when this passenger added, I have to add over here and retrain the model again. Retrain the model in the sense the data set, when I execute the data, the 400 records should turn down to 900 records. And then the training is happen again. Correct, Pawan. So this is the way, if that's why every day the server is down for 11:30 p.m. Yes, maintenance not happen on every day. Why? Isn't it, guys? Maintenance, it's not happening every day. It's one day, but the model is training on every day. That is the reality. Understand, guys, everyone? Yeah. So here, this is all SVM model, guys, we build. This is what SVM model. Now, the next one, before I go back to thing, I shared you some of the work to, I mean, I assigned some of the work to you. Did you see this, guys? This one, SVM part, logistic. Are you started working on this one? Completed? Very good. Good sessions, guys. Good link or not? I mean, we understand how principal component is used. SVM classified tutorial, KNN. If you check this one, see, guys, if I explain this in the session, I cannot give you spoon feeding because this code belongs to this, that code belongs to that, isn't it? So here, if you see this, if it's clear cut explanations, okay, but SVM Chandrahas, it might work for you, buddy. It might work for you. If you see this one, please classify tutorials with Python. What exactly we're doing? Introductions to SVM, kernel trick, scikit-learn's library, datasets descriptions, EDA, feature scaling, default hyperparameter tunings, import SVC, right? This guy is almost done with all hyperparameter tuning and check with accuracies, right? So this is what we done. And also C equal to 100, the coefficient, we done with how much coefficient? 1.0. Yes. Can you try to do 100.0? run SVM with RBF kernel and see 100.0. Understand, guys? So here we have seen that there are outlier in our data, so we should increase the value of C is higher. C means what, guys? Do you remember yesterday I showed the math equations? What is the math equations? The equation is W into B equal to, excellent, into or plus C error and epsilon size of the error. So whatever outlier is there, it will adjust the outlier here. So that's why as the data set which we build right now, there is no outlier. So I mentioned 1.0, but now as we have outlier, we need to increase this 100.0. Guys, get it? Yes. Are you get it, guys? Yes, Drakshayani. So that's why, because when I give some assignment, I already reviewed this and I shared with you guys. Run RBF kernel with C 1000. Did you check 1000? And let's check the accuracy. 98%, guys. Now, can we build with 100 and all those things? Can we try it once? So here, let's go for this one. The C value, let's copy this and kernel RBF. Let's consider the by degree, comma, C equals to 100.0. Yeah. So let me restart the kernel. Okay. And okay, even though for me, if I mentioned like degree equal to 4, let's check. Let's check. Same, because the data is very less. The data is very less. Okay, so that's why we're not getting any values. If you want, you can add some records and you can check it out. Okay, and also the future predictions, whatever I shared with you right now, guys, here, this is the final value. So now what you need to do today, so very simple. This is created by which model? Logistic regressions, right? I want you to create by SVM and KNN. 3 models you need to build today. Everybody's output should be equal. Okay, because same code, I already shared the code. Today I'll share the code, future predictions, and you're going to implement one Excel sheets, one code has to be printed all the output data frames. Yes, this is all these things. Now today I just wanted to implement one part is called sensitivity and AUC and ROC curve. Yeah, AUC and ROC curve. So let's go for this one. Can you close this? Okay, just 1 second. Just bear with me, guys. So here, I wanted to find out somewhere I keep it that one. Just 1 second. Somewhere 30 AM. Right. Let's go back to this one. Copy this and oops. Okay, so you know, guys, what is meant by precision, what is meant by recall, what's meant by true positive, true negative, and all those things. We know this, right? Now today, classifications metrics, you know this, F1 score, you know this, right? And this is all interview questions. All right, so let me show you some of the questions patterns and we're going to see this. Okay, I'll give 180 question bank to you, everyone, at last. At end of the sessions, end of the day, Everybody needs to complete this 180, guys. Once you're done, definitely your things will be clear. So for example, what exactly the questions looks like, if you check this, okay, what is entropy and information's gain in decision tree? What is pruning in decision tree? Okay, how PCA works, and after implementing PCA, what will happen? Anybody responds to these questions? How PCA works, and the online team, can you hear me? Online guys, can you hear me? Yes, Nishu, Surya Prakash, Arvind. Yes, it reduced the overfitting, and it called as dimension reductions techniques, right? Yeah. So what will happen after applying PCA? What will happen after applying PCA, guys? Exactly. Reduce, so that the overfitting will reduce. Model validations techniques. Do you know what is the model validations techniques? This is what you'll ask by an interview, guys. What is model validations techniques? I will tell you. I will tell you. Dimensions happens. I know, Prasanna. Yeah, yeah. That's all about PCA, correct? So now, okay, skewness of the data, we done this. Okay, what is meant by Hing functions? What is momentum and gradient descent? Anyone? What is momentum and gradient descent? What is momentum and gradient descent, online team? When we try to reduce the learning rate, okay, we try to reach the global minima, isn't it? Let me tell you guys, this is all questions you will encounter in interview after complete your session, maybe 2 months when you attend interview. So these are the questions they will cover up. What is eigenvalue and eigenvector? What is eigenvalue and eigenvector? In PC, I was talk about this. Yes. In PC, I was talk about eigenvalue, eigenvector. So it will generate from matrix, covariance matrix. Yes. And if I C minus lambda equal to 0, so lambda, it becomes eigenvalue, isn't it? How to find which model is best? Did you check the question? How to evaluate which model is best? What is the answer, Subhashmita? You build all the model. How to find out? Can you, no, you research and tell me tomorrow. Okay, guys, everyone, how to evaluate which model is best? Accuracy, that's okay. That's a, okay. Confusion matrix, right? By confusion matrix, you get accuracies. What is ROC curve? We never talk about this. Vanishing gradient descents, did it back propagations? No, we didn't talk about this. Yeah. What is loss functions? What is loss functions? Minimize the between predicted. These are loss functions, right? What is gradient descent? Archana, voice is breaking. I'm sorry because I'm connecting from hotspot because the office net is down. So I just connected from my laptop. I'm sorry, my phone. Now it's manageable. Is it fine now? Okay. Is it fine now, Archana? Yes. All right. So difference between word embedding, TF-IDF and word embedding, NLP sections, we haven't covered up. Okay. And Sadiq, what is sigmoid function, Sadiq? What is sigmoid functions? We learned? No, sir. When you talk, I was in Bangalore. Yeah. Not works out, buddy. Now, next one, sigmoid functions. You know this, how to get this one? Yes, sigmoid curve. How to handle imbalanced data set? Online, guys. How to handle imbalanced data, oversampling and undersampling. Did I explain? No. Smoothie techniques, guys. Synthetic minority oversampling technique. Do you see the sessions versus real-time interviews, both differences or not? Understand or not, guys? This is what you encounter the questions in an interview when you attend the interview calls, guys. But in the sections, in the training sessions, we will go slow by slow. So that's what this notes, whatever I prepared, you will understand later part. What is the powerful of this notepad? Okay. And can we discuss what is precision recall? Yes. So What is hyperparameter and name some random forest and SVM? Okay, good questions. Can anyone tell me? Can you tell me, buddy, what's your name? Srikant. Sriram, can you tell me this one? What is hyperparameters and name some in random forest and SVM? Forget about random forest. What SVM? Just now we done. Kernels, kernel coefficients, kernels, SVM, poly, and all these kernels, right? Yeah. So what is dummy variable and why we need to delete it? Anyone? Guys, are you understand? Can we discuss few questions like this? Dummy variable is an encoding technique. Do we need to delete this, Kirtana? No, sir, don't ask me. I have to fly. Yeah. You need to delete. On which part we need to delete? Let me tell you. So let's say C, Chennai, Hyderabad, and Bangalore. So this is C, H, and B. C, C1, rest of things 0. H is 0, 1, 0, and 0, 0, 1. So this is one hot encoding. Yes. Label encoding, if I remove this, it's not make sense. You can delete this variable as well, isn't it? Yes or not, guys? So this is what interview questions. Team, are you understanding or not? Why I was talking about this interviews? So this is what you're gonna ask in interviews, guys. So online team, Wasim, everybody's clear, team? Yes, guys. Yeah. We need to delete the dummy variable to get the accuracy. No, wrong statement, Avilasha. Wrong statement. We need to delete the dummy variable to make the data set into equal scale, right? Dummy is categorical variable, then we change it to numerical, right? And then what is one hot encoding, Avilash? What is one hot encoding, Avilash? Huh? Categorical to numerical. Very good. Zeros and ones. Excellent. Okay. So what are the assumptions in logistic regressions? What are the assumptions in logistic regressions? Write down these questions. Write down these questions. What are the assumptions in logistic regressions? And you tell me tomorrow the answers. Okay. What is difference between regressions and time series? Okay, I didn't explain. We'll talk tomorrow, next week, next time. Feature extractions like PCA, LDA, K-based RFE, where we see this, RFE, recursive feature eliminations. Why we do this? Is this necessary? RFE, recursive feature eliminations. Of course, it is required to remove the multi-collinearity problem. Write down. RFE is used to remove the multi-collinearity problem. Yes, guys? I hope. What is ANOVA methods analysis? What is ANOVA methods analysis? What is ANOVA methods analysis? We completed analysis of variance. Rashmi, what is ANOVA methods? Don't know. Imran, what is ANOVA? Washim, now you started turn down the notes. In interview, this is what happened, guys. Please remind this one, okay? What is chi-square test? What is chi-square test? Shekhar, listen to me and answer. What is chi-square test? Don't know, sir. Huh? Okay, now I ask you two questions. Assumptions of logistic regressions, assumptions of linear regressions. Write down two questions. What are the assumptions? You need to tell me tomorrow. No, you check and tell me tomorrow. I'll wait. Okay, guys. Featured selections in machine learning. Sadiq. Sharvani, are you there? What is meant by feature selections in machine learning? RFE and wrapper methods, filter methods, embedded methods, chi-square test, and all those things, isn't it, guys? So Which regularizations used to reduce the overfitting? Which regularizations is help to reduce the overfitting? L1 or L2? What's your name, buddy? Your name, Sai. Prahlad, what's your, tell me, which regularizations? I don't know because I saw IPL. All right. What is T-test and G-test? You cannot speak like that. T-test used for sample data, F-test is for populations data. It's not works out. You have to explain. These tests we perform to find out hypothesis for the data. Yeah, you need to L1 and L2 regressions. Yes, skewness of the data. What is difference between skewness versus cutoffs? Why we get this in skewness? We check how the data is skew, where the data is asymmetry. Which one we need to consider? Positive, negative, or equal? Positive. Yeah. In positive, what happened, guys? Mean equals to median equals to mode. Yes. Yeah. Topic modeling we didn't done yet. Ensemble learning we didn't. Forward selections, backward eliminations. Anybody? Churn modeling. This is what your projects model. Yes. So cross validations, bias and variance. Anyone? What is bias variance trade-off? What is bias variance trade-off? Not even if one person's give me a proper answers. This is not workout, Sumit. I'll tell you. You have to give a proper explanations. And the moment when you say he should be liked your answers. Understand? So please let me tell you guys, you know this, a lot of people, you know why they didn't clear the interview? They know the concepts. They think if I tell these answers, maybe he'll think incorrect. So that's the not right approach. Yes, Avilash, you're laughing. Correct or not? Yes, you know the concepts, but when you speak, what happened? It will blur. So that's why you have to give 2 to 3 rounds. All right, R square versus adjusted R square. Let me tell you 1 second. Regularizations, bias, variance. Can we discuss or not discuss, guys? Can we go to the topic or we'll discuss? Understand, let's discuss few of the questions and answers so that tomorrow when you prepare some of the resumes, I need minimum few of us I know who will get, who will not. Yeah. What is the difference between regularizations, bias, and variance? So how do you explain? Someone ask you. It's a question and answers PDF share. See, Rihan, it's not the matter of share. It is the matter of how do you respond. Anyway, I will share. I will share the question and answers for more than 1000 questions. If you, same thing, if you keep it on your laptop, it's not works out, isn't it? Yes, guys. What is R square, adjusted R squares? For simple linear regressions, can we use R square or adjusted R square? For simple linear regressions, we can use R square. For adjusted R squares, we use for multiple linear regressions, right? Excellent, Avilasha. And how can we prune in decision tree? How can we plot all the cluster? No, we didn't done this. Clustering algorithms, no. K-means KNN, exactly. Complete explanations about K-means clustering and K-means algorithm. I will give you one case studies right now. Let me tell you the dependent rating of a meal. What I'm saying? So just close this one. Rating of a meal. What could be the rating? Let's say if I range between 1, poor, food is not good, 2, food is okay, 3, food is average, 4, food is tasty, 5th, food is delicious. This is the dependent variable. Understand? This is the dependent variable. Now, dependent variable. My another questions. Can I use regressions, classifications, or clustering? Can I use regressions, classifications, or clustering? Because why clustering? Don't you think the variable is continuous? We cannot use classifications, understand, right? But can I use the rating of ML regressions or clustering? Which one? Regressions or clustering? Clustering only, because I am saying the variable is continuous. After the 5, there is no continuous variable. If a new data point add, let's say 5% rate for ML 3, 4, 5. If 6 persons come, he will rate between 1 to 5 only, isn't it? He will rate between 1 to 5. He doesn't rate 6 part. Guys, are you understand or not, everyone? Okay, so this is called some of the use case statements. Now let's get back to this one. So tomorrow I will give you one problem statement, which I asked to one of IIT student recently, and I'll talk this interview tomorrow. Okay, so let's see how many of them are answers. You take some time and you then let me know. Okay. Model validation techniques, write down, guys. These are questions. Model validation techniques, assumptions of linear regressions, assumptions of logistic regressions. All right. And then, okay, stemming, I'll talk about this one. Sigmoid functions, why do we use it? Why do we use it? I explain in detail. Think and answer. Wrong. Why do you use sigmoid? Sadiq, why are you laughing? Excellent. Because of the outlier, you have to add the outlier point. Because of the outlier, the regressions line is changed. Understand? Yeah, that's okay. That's okay. So because of the outlier, okay, what happened? The syntax, I mean, the condition is failed. So that's why we need to impute the probability part, right? Right. Next one. What is ranking algorithms? I'll tell you. So does MAE has a gradient? Can you write these questions, guys? Does MAE has gradient? Mean absolute error has gradient. What is ML pipeline? What is machine learning pipeline? So in interview, the first questions, explain your projects and explain your project pipeline. There's a two things. So what is machine learning pipeline? Write down these questions. I'll talk to you later part. All right. Difference between list and array. You know this, isn't it? Difference between matplotlib and pandas. Avilash. Matplotlib and pandas. Advanced visualizations. Data frame. What is difference between map and filters? Can you write down map and filters in Python? Okay. Null hypothesis in linear regressions. What is online team? Are you there or you're leaving? You're leaving, guys? Okay. What is hypothesis regressions? If all the coefficient of the variables is 0, can I say null hypothesis? Yes or not? Let's say y equal to mx plus c or y equal to m1 x1 plus m2 x2. If m1, m2, m3 becomes 0, can I say null hypothesis in linear regressions? Can I say this, guys? Yes or not? Yes, team. Online, guys. Washim, Drakshayani, Sinduri, Yasin. Surya Prakash, I hope you understand. Abhilasha, Abhishek, Ajay, Archana. See, guys, I post my number. All right. So we can talk if you have any questions. Arvind, Ashish, Ashok, Chandramali, Drakshayani, everyone. Mansoor, Pratyush. Sorry, guys, I'm not taking your name. Don't mind. Don't scold me. All right. So anyway, I'll just touch with you. No problem. Okay. So the next one. What is machine learning framework? Everyone. Scikit-learn. Yes. Scikit-learn. What is deep learning framework? TensorFlow and Keras. Very good. Various types of bias for sampling. What is bias and variance? Can you tell me difference between SVM and KSVM? SVM and KSVM. Kernel SVM, guys, right? So KSVM means kernel SVM. And another one is non-linear SVM, we also called as KSVM. Team, are you clear? Non-linear SVM also we called as KSVM. Okay. So why neural network is a non-linear? I'll talk about later part. Elbow methods. Okay. How to choose right ML algorithms, guys? It's very interesting since the question is, you said, sir, I worked ML projects and you put some experience of 4 years. You go for interview. Very simple questions you encounter as how to choose ML algorithms. Naresh IT told me, right? Now, what is the techniques we need to follow, guys? It's a valid questions or not? Very simple, man. If the dependent variable CNN algo, I ask one question, you ask different questions. CNN algo when you will teach, sir. See, this is what Chandrahas, give me the answer, buddy. I will teach at end of the sessions. Yes, computer vision, CNN, all those things. Understand? All right. Okay, so let's discuss tomorrow for rest of things. Requirement there. If your project, this is not, I'm not explaining your project's detail. Again, I'm saying in my batch, everybody is a student. Okay. Yeah. All right, guys. So what difference between logistic regressions and sigmoid functions? Difference between logistic regressions and sigmoid functions. Sigmoid functions used in logistic regressions, right? And the sigmoid functions ranges between outlier to 0 and 1 and all those things. Clear? Kirtana, when you go to US to learn data science, this is what only they will teach you, not more than that. Trust me. Understand? Okay. Thank you, guys. That's it for today, and see you tomorrow. And we will work on AUC ROC curve. Your name? I'm sorry, I forgot. Suchendra, understand, right, buddy? Yeah. You see, there is a lot of variations between learning to the real-time interview questions. This is not prepared. My friends, some of them that attend interview, they encounter with these questions that they've been written, and we maintain these documents. And I'm going to share with you at the end of the day. Clear? Thank you so much, guys. See you tomorrow. I will share this notebook and practice and make a future predictions for all of things. Yeah. Thank you. You can try, guys, the code which I shared you, maybe you work for your projects and something like that. Okay. Okay. Jade, clear. Yasashri, Washim, Chandrahas, Sushma, Sunita, Shubham, Sinduri, Shiva, Satyajit, Sakshi, Rohan, Rihan, Pratyush, Pavan, Nischit, Mansoor, Drakshayani, everyone, Chandramali, Arvind, Archana, Ajay, Avilash, and Surya Prakash. Okay. Thank you. Thank you, guys.